In this video, we're going to be looking at filling in the unit circle. Specifically, we're going to fill in this quadrant in the best of our ability, and after filling in this quadrant, we're going to correlate those values accurately across the unit circle into the other quadrants, because again, it's understandably that we're filling in this unit circle on an x, y coordinate plane. So before I get heavily into the concepts of filling in this unit circle, let's start with the values that make the most sense. If we're on a unit circle, that means that the length from here to this point right here is going to be a radius of 1. If that radius is going to have a value of 1, that means my x coordinate is 1 and my y coordinate is 0. I can fill this in for every single quadrantial location. So this over here is going to be 0, 1. This one over here is going to be -1, 0. And this one down here is going to be a 0, -1. So I filled in all of those locations. The next piece that I'm going to go ahead and fill in is the basic values of the angles for those locations. It's really understandable that we have to understand that the angle, the central angle in here, is going to be from here to here 90 degrees. From here to here is going to be also another 90 degrees. So if I go from here all the way around to this location over here, that should be a total of 180 degrees. So I'm going to do what I would normally do with this, and I'm going to count in respect of 90 degrees. Now, I don't like 90 degrees. I really don't like degrees at all. I'm going to go ahead and do my radian measure in this location here and my degree measure in this location. I'm going to start with the degrees just because I think that you guys will better understand that first. So this is 0 degrees. I'm going to move up to this location up here. I'm going to write 90 degrees. Then I move down to here. That's 180 degrees. When I move over to here, that's going to be 270 degrees, keeping in mind that all I'm doing is I'm adding 90 every single time. Then when I get back to this line right here, I'm repeating the same location. Remember that trigonometric functions are cyclical in some way. They start repeating themselves after a certain amount, but 360 degrees, and then I can continue to count if I want to. So this would be 360, then we're going up to 450, then 540, then 630, and so on and so forth. So now if I want to count in regards to radian measure, the radian measure at this location is still going to be 0, but now when I go from up here to up here, remember that radian measure, that pi is equivalent to 180 degrees. Well, halfway between those two locations, if I cut pi in half, then that'll be my 90 degree measure. Now what I'm going to do here is I'm going to count to get this one, because maybe we're not comfortable with identifying what that value is. Well, I have 0 pi over 2's, I have 1 pi over 2, I have 2 pi over 2's, which simplifies down to pi, and then I have 3 pi over 2's, because again, I'm moving a 90 degree measure. I have 3 pi over 2. Then when I move over to here, it's 4 pi over 2, which is really 2 pi, and it does match up that 2 pi is 360 degrees. So we found the main quadrantial values. What's important next is for us to remember that every single one of these coordinate systems here, they correlate to some value of sine and cosine. It's also important for us to remember that the coordinate system is always going to be the cosine of theta, comma, the sine of theta. So what's best understood is, if I'm looking at these quadrantial values, keep in mind that we couldn't do this before. We couldn't find sine and cosine of values that were larger than 90 degrees because we're supposed to be working with these trig functions in a triangle. And now that we're removing ourselves from the triangle, we're defining this in a slightly different way. It's allowing us to elaborate and extrapolate upon the sine and cosine function. So let's just verify some pieces of information here. The cosine of theta, where theta is 0 degrees, the cosine of 0 degrees is going to be 1. That's how we utilize this unit circle. So if up here I wanted to know what the sine of 90 degrees is, the sine of 90 degrees, well, there's my 90 degrees, the sine is the y value, it's going to be 1. If I want to go ahead and know what the cosine of 270 degrees, or more appropriately 3 pi over 2, then I'm going to go over to 3 pi over 2, if it helps, and you don't remember your unit circle, 1 pi over 2, 2 pi over 2, there's 3 pi over 2, and I want cosine, the cosine's the x value, so that'll be 0 again there. So this is the basics of how we're going to utilize this unit circle to identify certain values. Again, the goal of this is to help us memorize information in a better way so that we can more easily identify information when we need to. Now, The next piece we're going to have to do is we're going to have to superimpose these special value triangles that we did in 4.3 video number 2. We did this one here with the 45, 45, 90. Now in this unit circle, 45 is going to be this middle dash. Okay, if you'll notice, and I cut this down, I'm gonna do it in dotted lines here. If I cut this all the way down, that's gonna create me a 90-degree triangle such that that marker right there and this angle right here correlates to this exact same thing in the grand scheme of the problem. The one thing that changes in the grand scheme of the problem is that this value is supposed to be a 1. Well, if this value is supposed to be a 1, then these two values get shifted appropriately to be, well, this radical 2 over 2 value. That's the convenient way that this particular problem works. So if this right here is supposed to be 45 degrees, which should make sense given that it's halfway between 0 and 90, that means that this is going to be pi over 4, because pi over 4 correlates to 45 degrees. And my sine and cosine value, cosine coming first, radical 2 over 2, sine value coming second, radical 2 over 2, I'm just superimposing again this 45, 45, 90 special triangle into that location. Now, to fill in the rest of the values, before I go any further with the x and y coordinates, let's count the degree measures. I have, now again, I don't really like counting these degree measures, but we're going to have to do it. I go from 0 to 45, I add 45 to that, I get to 90, I add 45 to that, I get to 135, 45 to that, I get to 180, 45 to that, I get 225, 45 to that, I get 270, 45 to that, I get 315, and sure enough, if I add 45 to that, I get back to 360. So notice how, again, every middle dash is going to correlate to a counter measurement of 45 degrees, where again 145, 245, 345, 445, 545, 645, 745, and 8 of those 45 measures. Then here's the kicker. I prefer the 45 pi over 4s more because I have 1 pi over 4, I have 2 pi over 4, I have 3 pi over 4 right here, 4 pi over 4, which sure enough simplifies down to pi, 5 pi over 4, 6 pi over 4, which simplifies down to 3 pi over 2, and 7 pi over 4. Then we're back to 8 pi over 4, which is nothing more than 2 pi. So I can easily, again, count the 45 measures in one type of unit circle. Now, I'm filling this all in on one unit circle, but it might be beneficial if you do this in 2 separate circles. For instance, get yourself another copy of this page somewhere, and then fill in these other ones that I haven't done yet separately from the ones with the 45s, mainly because it's probably easier to see that way. I count based on the dashes. I don't count based on the location of these angles such that this is actually going to end up being 30 and this is actually going to end up being 60. I'm going to count based on 45s, or I'm going to count based on 30s, or I'm going to count based on 90s, or I'm going to have to manipulate the angles that I have. Now, let's talk about how these values over here simply just shift to this middle dash over here, because if this is a unit circle and it's on a xy coordinate plane, this x and y value should be exactly the same on this point as it is over here, because this circle, the whole circle, is symmetrical along the x and the y axis. So that means that this over here should be radical 2 over 2 and radical 2 over 2, except for because it's in the second quadrant, first quadrant over here, second quadrant over here, third quadrant down here, fourth quadrant over here, I should have a negative x and then a positive y. So that means that should be a negative value. I'm going to do this also down here. I'm going to go ahead and note that this is supposed to drag down into this middle dot right here. It should be symmetrical there. So over here I'm going to have radical 2 over 2, radical 2 over 2, where both of them are negative. Because in the third quadrant, everything is negative. It's a negative x and a negative y. Over here, I'm going to have a positive x and a negative y. So I'm going to have radical 2 over 2 in that middle value, and then a negative radical 2 over 2 in the y value. So let's ask one of the basic questions. What if I wanted to know what is the sine of 7 pi over 4? Well, if it helps, 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. Yeah, I know it was there, but I'm going to count it as though it wasn't, because sometimes this unit circle is not sitting in front of me, and it might help for me to correlate that counting to an easy identification of what dash I'm talking about. Also notice, for the counting measures, I always count for 45, the middle dashes as well as the axes, middle dash, axes, middle dash, axes, middle dash. axes. So 7 pi over 4. And I want to know what the sine of 7 pi over 4 is. Well, the sine is the y value, and therefore the y value is negative square root of 2 over 2. So now I know very quickly what is the sine of 7 pi over 4. Without actually memorizing these values, I can build this unit circle in the most efficient way possible. Let's go ahead and finish building this unit circle. Now we're going to do the same thing with the 30, 60, 90 triangle here, such that I'm going to convert this radius to now be a value of 1, and I'm going to judge or modify these two values appropriately. Keep in mind that the 30 marker is the smaller one in here. This is the 30-degree measure, so I'm going to put that in there, and then this is the 60-degree measure. Now, be understandable that I'm not actually going to work with the 60-degree measures. That's a lot of extra counting that I don't really need to worry about. I'm going to work with the 30-degree measures, and I'm going to correlate those ones appropriately. Now, all we're doing, just like we did here with these two values, we're going to shift these values where they need to be appropriately. So, the sine of, let's start with the cosine, because the x value is the cosine. The cosine of 30 degrees is radical 3 over 2, which means that here the cosine value, the x value, should be radical 3 over 2, while the sine value is 1/2. And if you look at the 60 marker, the 60-degree marker, the values are flipped. So I'm going to have 1/2 here and radical 3 over 2 there. So I now have the majority of the first quadrant filled in. The only thing I have to do left is the pi over 6 for this location. Pi over 6 is equivalent to 30 degrees. And over here I have to do the pi over 3 value. Now, once I've got all this information down, these points are supposed to shift over again symmetrically. So over here I should have a negative 1/2 and a positive 3 radical 3 over 2. I should have a negative radical 3 over 2 here and a positive 1/2. Down here I should have both negative. Now again, be very careful of the dots. This dot should carry down to the closest dot to the x-axis. This is the closest dot to the x-axis. This is the closest dot to the x-axis. So it should be negative radical 3 over 2 and a negative 1/2. Just like this one should flip, negative 1/2 and negative radical 3 over 2. This is not complicated. There is no mathematical information happening here. I've taken the mathematical information from the two triangles that I built, and I'm superimposing them into this location. And then I'm simply using rules of basic coordinate system to transpose the values across this plane. So I'm going to have a positive x and then a negative y. Since these two values are here, they shift down into this location. So I have radical 3 over 2 and 1/2. And I know that the y value is supposed to be negative. Now, once I have all this information filled in, the last thing I need to do is make sure that I appropriately count the angle measures and how they situate. I'm going to do the same thing I did with the 45 marker, except for I'm going to count based on pi over 6s. I'm going to skip the 30 degree and the 60 degrees. I'm going to skip the degrees. I'm going to go straight with the radians. I have 1 pi over 6. I'm going to count the first dash, then I'm going to count the last dash before the axes. So 1 pi over 6. This right here is the same thing as 2 pi over 6, which does simplify down to pi over 3. Then I'm over here at 3 pi over 6. Notice how I'm counting dash, other dash, and then back to the axes. In every single counting system other than the 60-degree counting system, which we're never going to use, at least I'm not going to teach it, we're going to start with pi over 6, 2 pi over 6, 3 pi over 6. We always count the dashes and then the axes. So here's 3 pi over 6. This would be 4 pi over 6. This one down here will be 5 pi over 6. Now notice how the 4 pi over 6 I wrote over here, not on the bar. The reason why is because the values closest to the y-axis. Notice I had to simplify this one to get this value, so that means I'm going to have to simplify this one to get the next value, which is 2 pi over 3. So I'm going to keep doing this. I lost count. Let me start back over. 0 pi over 6. 1, 2, 3. 4, 5, 6 pi over 6, which is sure enough pi. Here is 7 pi over 6, and I'm comfortable writing that directly on the line because 7 pi over 6 is closest to the x-axis. It doesn't need to be simplified. Then I'm at 8 pi over 6, but I'm going to write that over here, and I'm going to simplify that down to 4 pi over 3. 8 pi over 6, then 9 pi over 6. Don't forget to count the axes. 9 pi over 6 to 10 pi over 6, and 10 pi over 6 should be simplified down, and then 11 pi over 6. And sure enough, when I get to 12 pi over 6, I'm right back at 2 pi. Right here, this location will be simplified down to 5 pi over 3, and now I have every radian measure. If necessary, we can go ahead and fill in those 30-degree markers, 30, 60, 90, this is going to be 120. This right here is going to be 150. You'll notice also that each marker is separated by either 30 degrees, 150 to 180, 120 to 150, 90 to 120, or it's separated in the middle dashes by 15, 120 to 135, 135 to 140. So if we're struggling with knowing what values here are going to match up, we'll just add 15 degrees to this. This will give me 230, 40, 240, and over here should be 210, because I'm going to add 30 to this to get to here. I'm going to add 30 to this to get to here. I'm going to add 30 again. I'm going to add 30 again, and I'm going to add 30 for the last time. And this fills in the entirety of the unit circle. Now, anytime you're asked to find a specific trig value of any angle, we should be able to efficiently use this unit circle to find that value. I did one example during this video. I'm going to do at least 4 or 5 more in another separate video.